Once again, good morning or afternoon, depending on what part of the country you're in. Thank you for joining us for today's webinar about radars and traffic data collection. We will be allowing time for questions at the end of the presentation, so please use the question feature at that time. My name is Sheri Rowell. I'm the account manager in Western Canada for Stinson ITS. For those of you not familiar with Stinson ITS, our head office is in Concord, Ontario, and I'm based out of Calgary, Alberta. Stinson ITS Inc. is part of the Stinson group of companies, which has been in the traffic industry since 1960. Our focus is on intelligent transportation system products. Stinson ITS has now moved into its own offices, and for those of you in the Toronto area, we hope once things get back to normal, you might come and visit us. I know that Michael, Brian, Ajay, and the team would be happy to show off our new digs. Stinson has been working with Houston Radar for over 5 years now to provide traffic counting equipment. Casey Inouye from Houston Radar has joined me today. Casey, please take a minute to introduce yourself and tell us a little bit about Houston Radar.
Thank you, Sheri. My name is Casey Inouye, and I'm the Business Development Manager for Houston Radar, which primarily involves providing sales support for our retail line of products to our partner and distributor network. I joined Houston Radar in 2019, and I'm pleased to present today with Sheri and Stinson ITS. Houston Radar is headquartered just outside of Houston, Texas, and was started in 2004. The company first began offering radar devices that we now consider our OEM products, and we've become a leading provider of radar-based traffic products around the world. A few years after our start, we began producing the devices that constitute our rapidly growing retail line, which we will be discussing in part today. We have products deployed in nearly 60 countries across 6 continents, and we just moved into a brand new headquarters and manufacturing plant this past spring. Now back to Sheri.
Thank you, Casey. I just want to let everyone know that we will be giving away a few prizes at the end of the presentation. You will have to answer a skill testing question or two in order to have a chance to win. I find history interesting, so I decided to do a little digging to see what I could find out about traffic data collection and when it started. I found a US patent filed in 1928 by David Katz for an early automatic traffic detection device that was based on using the Earth's magnetic field. For close to 100 years now, we've been developing technology to understand traffic. By the early 1930s, there were over 26 million cars registered in the US and over 1 million vehicles registered in Canada. Today, that number of vehicles is estimated in the US at 263 million registered vehicles and over 36 million vehicles in Canada. Accordingly, the network of highways, service stations, and motels has grown to accommodate the ever-increasing use of automobiles in North America. In the late 1920s and early 30s, most traffic counting was done by manual counts. As early as the 1920s, cities and municipalities were looking to understand traffic volumes and how it will affect their planning and growth. Road tubes, or a form of them, started to be used in the late 30s and into the 40s. This type of equipment offered mechanical counts, and this changed the integrity of the data being collected. I found a 1973 Popular Mechanics article and a picture of a counting device chained to a pole. The devices are a little bit smaller now. By the 1970s, computerized pneumatic traffic counters revolutionized traffic data collection. We started to see radars, video processing, and artificial intelligence in the 1990s, which once again changed data collection, the type of data, and the amount of data that could now be collected and analyzed. Traffic engineers assess, present and future traffic issues by measuring or estimating traffic volumes, speeds, vehicle classifications, levels of service, delays, and queuing. To prioritize, plan, and act on present and future traffic issues, data-driven understanding of the traffic across your city or municipality is critical. What are the traffic volumes, operating speeds? How many trucks are on your roads? What is the level of service? Some of these are questions that you ask about your different roadways. How are bicycles and pedestrians interacting with traffic? What are your active transportation initiatives? The key concept to understand is that data is everything. It enables decisions across all aspects of a traffic department. This is a continuous cycle, gathering data, analyzing the data, using the data to look at short and long-term plans, implementing those plans, and then repeat, gathering the data, analyzing the data, and onward. It is because cities and municipalities are dynamic, always growing and changing, that we need this continuous cycle. We're starting to see an appetite for live traffic data. Traditional data collection involved offline sensors being used to collect data that would be stored in a database for evaluation at a later time, if and when needed. Now what we are seeing, and especially with COVID, is the desire to see live traffic data, allowing for immediate analysis and data sharing. We can now watch the news to see what the drive to or from work is going to look like. Shared data drives today's traffic reports. Congestion can be detected and alerted on in real time, as well as statistical data can be shared with stakeholders just a day or two after a change in a lockdown policy. Multimodal data is also becoming important in the lockdown. Using this data, we can monitor the massive swings in pedestrian and bicycle volumes, coinciding with huge drops in light vehicle and bus volumes. Devices are typically thought of as intrusive or non-intrusive. Intrusive is where the equipment installation is on or under the roadway surface. These include inductive loops, which were first used in the 1960s and still used today. Road tubes, as we talked about earlier, were first used in the late 1930s. Magnetometers and magnetic sensors started to see use in the last 20 years. One drawback to this type of equipment is the installation process and maintenance, which usually involves traffic lane closures, and there is the potential for personnel safety. Non-intrusive, as the name implies, does not require installation on or under the surface of the roadway. Cameras, typically a permanent installation, but there are portable units in use. Manual counting, which started it all, tends to be used for smaller data samples and short duration counts, and will continue to be used in specific count applications. Radars, as the radar technology has improved, radars have become more commonly used in the last 20 years. This type of equipment is often mounted on poles near the shoulder of the road, limiting potential personnel safety issues and no need for traffic lane closures. Early last year, the Ontario office did a project to evaluate the different types of counting technology. Let's take a look at the results of this project. Manual counting has been around the longest and is typically used for temporary count stations. It offers counting and classification, but no speed data is collected. It is a lower cost option. Most centers outsource this as they do not typically have staff to perform this function, and the accuracy levels can be affected due to human error. It is also challenging to get multiple lane accuracy. Road tubes, we believe have been around the second longest, are typically used for temporary count stations. It provides both counts and speeds. In the Canadian climate, the use tends to be limited to the summer or warmer seasons. Accuracy can start to degrade due to the wear and tear on the tubes as they are exposed to increased traffic. There are potential safety issues as operators need to enter lanes to secure road tubes, which involves lane closures. Loops started use in 1960s. They're used for permanent count stations and are very accurate for vehicle counts, but no speed or vehicle classification. Installation initially impacts traffic flow. Loops can fail due to pavement conditions such as heaving caused by freezing or thawing in the northern climate. LiDAR, which is a newer technology, is used for permanent and temporary count stations. It provides speed and counts. Weather can affect the overall accuracy. This is an up-and-coming technology that bears watching as companies work with it to refine the technology. Radars, our focus for today, used for both permanent and temporary count stations. It offers count, speed, and vehicle classification. It's operational in all weather conditions, so year-round availability, low maintenance, low capital, and operational costs. Video analytics tend to be for permanent locations. Again, there is portable units available. Offers count, speed, and vehicle classification. Weather, such as fog, rain, or heavy snow, can impact accuracy levels. Video analytics continue to improve through machine learning and artificial intelligence. I'm going to let Casey talk about the radar technologies.
Thanks, Sheri. The term radar came into use during World War II as an acronym for radio detection and ranging. It's a detection system that uses radio waves to determine the range, angle, and/or velocity of objects. Radio waves are transmitted from an antenna, then reflected back from an object to a receiving antenna. The nature of the reflected waves is analyzed by a processor to give information about the object's location and/or speed. Doppler radar, also called pulsed radar, was the first radar technology used in the traffic industry. The Doppler radar will send radio waves in very short durations, repeating as necessary for the application, kind of like a heartbeat pulse. Information about the detected object is gathered by measuring the time delay between the transmission and return or reflections of the radio waves. For traffic detection purposes, Doppler radars may be preferred for their low power consumption, as the drain from a signal transmission is intermittent. An example of a Doppler radar is the Houston Radar Armadillo tracker. Conversely, frequency modulated continuous wave, or FMCW, radar devices utilize radio waves continuously being transmitted and received. Instead of relying on measuring the time between signals, an FMCW processor also determines the difference in signal frequencies between the transmission and reception. The greater volume of reflected signals and the greater number of points of comparison give an FMCW radar system better range resolution than Doppler. An example of an FMCW radar is the Houston Radar SpeedLane Pro. With this greater range resolution, the SpeedLane will provide measurements for gap, headway, and vehicle length. Because of the constant signal transmission, receiving, and processing, though, an FMCW radar will also use more power than a Doppler radar. Now, Sheri has some additional facts about radar detection to share.
So in this screen, we've just outlined some of the advantages and drawbacks for the radar products. We've talked about some of it already: increased accuracy for volume, speed, and classification. You do need to be cautious of the placement of the units, as the accuracy levels can be impacted by very low speeds or stop traffic. Radars have a low power use. Again, units can be deployed for 1 to 2 week studies on battery alone, or by adding a solar panel, they can be used in longer studies or for permanent stations. Once again, we need to be cautious of where we place them, put the units in an advantageous location. They're easily deployed, they're not impacted by weather, so again, year-round use. They're portable, small, lightweight units, even with the small solar panels. Compared to other technologies, they have a low purchase price and operational cost. Depending on the unit and the options that you have on the unit, they can start as low as $2,500. We're going to take a look at the equipment offering from Houston Radar. So understanding what your needs are for your specific traffic studies will determine which product is right for your application. The Armadillo tracker, we have a lot of customers that have been using this piece of equipment for a number of years now. When deployed in a median, can count 4 lanes of traffic and is very successful for 2-lane roads, 2 directions, or 2 lanes in 1 direction. Has a low power consumption, ideal for the shorter studies, 1 to 2 weeks on battery alone. With Bluetooth, it can be programmed at the side of the road with the phone app, and it allows you to see in real time the unit working. The unit can be set up in advance with the USB connection at your PC. The cell modem equipped units offer remote access to download data at your PC. Small, medium, and large pre-configured length-based bins allow for a 90% plus accuracy rate. The typical installation height is between 6 and 12 feet. It can be mounted at the side of the road. I have even seen one mounted on a tree close to a roadway. It is lightweight and can usually be set up and running in 10 to 15 minutes. The SpeedLane Pro offers up to 16 lanes of bidirectional traffic counts, speed, and classification. It is a side-fire dual-beam FMC radar that effectively creates a speed trap to calculate speed. Again, this unit has a low power consumption, not as low as the Armadillo. It will run up to 4.5 days on battery. Bluetooth and serial are standard. Ethernet and cell modem options are available. 98% count accuracy rate with an 8 user set length classification bins from 2.7 to 76.2 meters. The installation for this unit is relatively quick. It does need to be mounted at 20 to 25 feet, as it needs to be able to see all 16 lanes. There is an HD video camera on board that is used in the setup to make sure lanes are mapped correctly. Also, if you have the cell modem option, you have the ability to download snapshots where it's installed. You can live stream, or you can record video for up to 18 hours. The power options for this unit are PoE, AC, or solar. The solar panel needs to be at minimum 30 watts. We do recommend a larger panel in the northern climates. Typically used for permanent count stations, although I have seen this device used for temporary counts on a 4-lane bidirectional road. It was put up for a short study on a high volume road. Casey, would you like to add anything about these two pieces of equipment?
I believe you've covered all the main points there, Sheri.
Okay, we'll move on to the software platforms and reporting formats available, and I'm going to let Casey talk about those.
There are 3 interface choices for these Houston Radar products. Stats Analyzer is a Windows-based software that offers a full suite of configuration and reporting functionality. It is maintained regularly with new releases available for download from our website. An upcoming release will include a French language version, an effort which has been spearheaded by Stinson ITS. Stats Analyzer provides complete control over data from the tracker and SpeedLane probe. It includes nearly 40 canned reports, and you can filter some of these by direction, lane, time intervals, vehicle sizes, and speeds. You can also export data in 15 different file formats, most commonly Excel and CSV. Each installation of Stats Analyzer can communicate with one radar at a time, though you can combine data sets from multiple radars and across multiple time frames, and fetching the data is a manual operation. Some customers only utilize Stats Analyzer when working with Houston Radar devices. Houston Radar's Tetrion cloud server builds on the reporting functionality of Stats Analyzer and adds the conveniences of automated polling for data retrieval and a single screen browser-based interface with intuitive user controls. Users have all of the same reports without having to connect to each device individually and without needing to install any additional software. Tetrion is more of a fleet management tool. It's a subscription service and requires either cell modems or a wide area network. Each account has a unique non-searchable URL and supports an unlimited number of users per account. Houston Radar includes Bluetooth connectivity as standard in the tracker and SpeedLane, as Sheri just mentioned. We use a Class 1 antenna in each of these devices, which provides ultra-long range over 700 meters in the best cases. Our Houston Radar app for Android smartphones is compatible with all of these devices and is available for free in the Google Play Store. Our app has varying levels of functionality for each radar product. For the tracker, it can do everything Stats Analyzer does except view reports. And for the SpeedLane, you can adjust or configure the lane plot, view alignment through the onboard video camera, and utilize the full array of available ASCII commands. We have recently added Apple iOS compatibility, the first radar manufacturers in the industry to do so. Our Houston Radar app in Apple's App Store will provide the same functionality for the tracker that our Android app does. Apple compatibility requires a hardware upgrade and is available only for the tracker. While we're discussing reporting capabilities, I'd like to describe how these devices provide the data for your consumption. As just mentioned, the Stats Analyzer and Tetrion softwares both provide an abundance of reports in both table and chart formats. The most commonly used reports are based on interval data. Interval data is based on blocks of time, whether it be 5 minutes at a time, a month at a time, or anything in between. These common reports include an analysis, which is a summary of the data sets the user has chosen, daily, weekly, and monthly tables for counts and average speed and 85th percentile speed and speeders, and charts, which are line and histogram graphs to compare daily, weekly, or monthly data for those same data sets. For solar power units or units deployed only with battery power, you can track the power supply voltage and battery charge for each installation through its own report. If you're taking advantage of the tracker battery's 14-day runtime by conducting several counts at multiple locations before bringing it back in, you can view a map placing a push pin at every location at which the tracker was deployed. All of these reports are usually considered interval data reports because they use averages or combined data across time. However, every report and chart can be exported out of our software platforms to be used or disseminated as you see fit. You can have up to 39 different reports or charts, and almost all of them have filters you can apply for a more focused evaluation. Now, raw data is often considered the gold standard of data collection. Raw data is the record of individual vehicles and is the basis from which interval data is drawn. For the tracker, raw data includes a date and time stamp accurate to the 100th of a second, speed, size classification, the direction of travel, the lane in which the vehicle was detected, GPS coordinates, if applicable, and a unique chronological identifier. The tracker can store 315,000 individual vehicle records. Now, the SpeedLane Pro's raw data file includes 2 unique identifiers, project and import batch identifiers, plus speed, vehicle length in centimeters, direction of travel, lane in which it was detected, date and timestamp, again, accurate to the 100th of a second, gap between vehicles, and the range, which is linear distance from the radar to the vehicle. The SpeedLane Pro will store 1 million individual vehicle records at a time. Now, the abundance of this internal storage is especially useful for devices that you may not communicate with regularly. Having that much storage means you can either dedicate less time to fetching the data regularly if you use Stats Analyzer, or you can more easily weather like a cellular outage because Tetrion will pull all the data it notices as missing on its next poll. So even though we're providing dozens of reports that can be filtered in an extremely wide variety, having this raw data means you can manipulate the data into any consumable form you desire. For example, Stinson has developed an Excel workbook that uses raw data to generate report formats unique to, or at least preferred in, Ontario. I'll throw it back to Sheri now for our trivia questions for today.
Thank you, Casey. If anyone is interested in the traffic data analysis Excel sheet that Stinson ITS developed for the Ontario Ministry, we would be happy to share it with you. Please put your request in the question field. You can use your own data in this report or in this Excel sheet. And with that, we're coming to the end of the presentation. Now for the skill testing questions. What are the 2 types of radar technologies we discussed today? Please submit your answers in the question window. First 2 correct answers will receive a gift from us. Sam is going to be monitoring it and will announce the winners. Any luck, Sam? Do we have anyone submitting anything?
We do. The first person to answer correctly was Jeffrey. So you'll be contacted afterwards so we can get your email and your mailing address.
All right. For the month of February, we are running a campaign. If you reach out to Stinson and start a discussion about the Armadillo tracker or the SpeedLane and make a purchase or provide a PO within the next 60 days, we're offering 10% off the tracker and 50% off the Tetrion cloud service. And for the SpeedLane, we're offering 1 free year of Tetrion cloud service, so approximately $1,000 value. With that, we'll move to the next question. What are the 2 types of data formats available from the Stats Analyzer and Tetrion software? Any luck, Sam?
Yes, the first person who answered correctly is named Ryan, and we'll send you an email afterwards to get your mailing address.
At this time, we'd like to open it up for questions now. Please use the question feature to submit your questions, and Casey and I will do our best to provide answers. We can also contact you after the presentation for more in-depth conversation about any of the products that you've seen, or if you would like to know more about additional products that Stinson ITS can provide.
So someone asked, is reporting available in metric units?
Yes, it is. So the configuration for each of these devices will ask the user if they wish to use standard or imperial measurements or metric measurements.
How can we see the data the MTO has from Houston radar? Did you send that to us directly?
So when it's not the data that we'll share so much as it's the Excel spreadsheet. And if you're running your own, if you have raw data, you can import it into this spreadsheet to analyze your data.
What is involved in getting existing Armadillo upgraded to the iOS compatibility?
That's a good question. We offer hardware upgrades. That does need to be done at our factory in Houston, though. So if you are able to reach out to your sales rep at Stinson, then we will coordinate with them. We'll provide an RMA to have the unit shipped back to us in Houston. We'll install the MFI hardware, and then usually we turn that around in about 24 to 48 hours.
I see a few people asking if we can share the spreadsheet.
I think the easiest way to do with that spreadsheet will be to actually send it to you, because it is a very comprehensive spreadsheet that shows a lot of different ways that the data can be analyzed. So if you put a note in the question section saying, I'd like the spreadsheet, we'll get it sent off to you. And what we can also do, if we have lots of people interested in it, we can do a short training session on how to use the spreadsheet as well.
I also saw someone ask if we'll be emailing a copy of the presentation. We will be. Does the Armadillo provide gap and headway?
No, the Armadillo tracker is not able to gather that information because it's as a Doppler radar. It doesn't have the number of data points in order to generate exact measurements like that. So the SpeedLane Pro will be able to provide gap and headway and occupancy, and the Armadillo tracker would not.
Is rental available? Someone asked.
That is something that we can talk about.
How long does the battery on the SpeedLane last?
The standard internal battery that we offer from Houston Radar is a 96 watt-hour lithium iron phosphate battery. So with the really low power requirements of the SpeedLane Pro, when it's used as a battery backup like a UPS, it will power the device for at least 4 days. We do also offer external batteries because there are some climates, north of the water here from the U.S. that you guys might need a little extra solar panel or extra batteries than we might normally provide in the United States. But the internal battery is a 96 watt-hour battery.
When installing the radar, how important is the installation height? Given they would be installed on posts with signs already installed on them, 7 feet may not always be achievable.
So the answer for that is a little dependent on which device you're talking about. For the Armadillo tracker, the mounting height is not really all that important. Usually you would want it at least 6 or 7 feet up off the ground, but generally no higher than about 12 feet. And that unit is normally mounted very close to the road, so usually within 6 or 7 feet of the closest lane of detection. The SpeedLane Pro, however, is normally mounted much higher than that, and the correct mounting height is generally related to the offset or setback from the first lane. It's usually about a 1-to-1 ratio, sometimes 1 to 1.25. So for example, if the post that you're mounting it to is 20 feet from the closest lane of traffic, you probably would mount it 20 to 25 feet up in the air.
Can we use radars for traffic light control?
The two devices that we talked about today are both free flow applications, so neither of those would really be used for traffic signal control.
Where there are no light standards or signposts in rural highway settings, do you have any poles or tripods for the SpeedLane?
Houston Radar does not offer any poles, so I don't know. Oh, sorry, Sheri, go ahead.
I was just going to say I have seen the units put on tripods. I have also seen some customers have built their own pole, I'm going to say portable pole, that they've been able to put it on with some weights at the bottom of it. So there is ways around that. And like I said, I've actually seen a unit mounted on a tree at the side of the road or a fence post.
Someone says, I noticed that pedestrians and cyclists were not mentioned in your summary of radar solutions, but it was implied that it would be inappropriate because of low accuracy for slow vehicles. Many municipalities are looking for a single counting solution for multiple modes. Is there progress for active transportation modes using radar?
That's not an active development project for Houston Radar. We have had a bicycle detection product that has gone back into development. It didn't quite live up to our expectations for accuracy. We don't have a pedestrian solution. Perhaps Stinson has other solutions that they carry.
And we do at this time. We have been looking at LiDAR because LiDAR has talked about being able to count bicycles and pedestrians. We're still exploring more with that. There is also, as people are probably aware, we have MyoVision, which can count pedestrians and cyclists as well, typically used at intersections. So there are other products out there for that.
When setting up the radar, does it configure itself when it starts the assessment, or does the person installing the unit have to input the physical location? Example, distance from the roadway, height above the roadway.
So the distance from the roadway and the height of the roadway, if I understand the question correctly, those numbers, those measurements are not generally needed to directly be inputted into the SpeedLane, for example. The SpeedLane during installation has an installation wizard, and during one of the steps of it, it will show you detected traffic and potential targets, and you build the lanes around those. So there are physical measurements included with that, though they're not necessary in order to complete the configuration. For the tracker, the lanes are automatically detected and assigned, and you do have the ability to go back and manually edit those. If for some reason in your detection zone there is a stretch of road, for example, an additional side street or parking lot that you don't wish to include in your data, then you can manually configure it. And with the SpeedLane, though, you will always want to manually configure it, though there is a visual guide to use.
Someone asked if you could please elaborate on issues related to reflective surfaces. What about sun glare?
So sun glare doesn't have an effect on either of these two devices. The particulates in the air are more likely to affect a Doppler radar, such as the Armadillo tracker. However, we use an advanced algorithm that kind of filters that out. We call it just a software filter. An FMCW radar, like the SpeedLane Pro, is not subject to any interference from sunlight or rain or snow or fog.
What are advantages or disadvantages over the Black Cat?
So the Armadillo tracker is more closely aligned to that device as far as specifications go, though the battery life in the tracker is longer than the other device. It also is capable of detecting up to 4 lanes of traffic. I believe the limitations on the other one is 2 lanes. So if there is a 4-lane divided highway, one tracker could be used to cover the entire detection zone as opposed to having to get 2 devices. I believe, from what I know about the Black Cat, it's a very good device. That's a quality company that makes it and produces it. But those are just a couple of the differences that come to mind off the top of my head.
Do you have any devices tracking vehicles for origin destination?
I'm sorry, I didn't quite catch that, Sam. Was that a question for me?
Yeah, either of you. Do you have any devices that track vehicles for origin destination data?
Houston Radar does not.
Houston Radar does not, but Stinson does have a device for that. The AIS is something that we've produced ourselves, so that's something that I can provide more information on. I'll see who asked that question and reach out to you.
How many vehicle classes for the Armadillo?
There are 3 preset classes that are classified in the data report as small, medium, and large. The approximate size ranges of those are under 4 meters for the small, between 4 and 7 meters for the medium, and then above 7 meters for the large.
Does the unit have to be installed on a very firm support? For example, mast arm of signal poles may bounce up and down.
Both of these devices have a little bit of forgiveness built in for sway. Of course, the more stable the mounting surface, the better. So for example, it also depends on the range of the detection zone. So with the SpeedLane Pro, if you have it mounted 25 feet off the road and 25 or 30 feet up in the air, you might be allowed a little bit more wind sway than if it was 10 feet from the road and 15 feet up in the air, just because the detection zone is compressed at that point. But the more stable, the better. Sheri mentioned that she's seen these devices mounted on trees. We would not recommend it be mounted on trees. I understand you got to do what you got to do sometimes, but we would recommend that it be mounted on, even co-located with some other type of signage or post that is, either already housed there, or Stinson has experience, of course, putting their own installations in. They can speak more prominently and correctly about the nature of those mounting surfaces.
Is there any impact on radars' efficiency during heavy rain or snow?
So again, with the SpeedLane Pro as an FMCW radar, there's no impact. With the Armadillo tracker being a Doppler radar, it is more likely to be impacted, especially than the SpeedLane Pro. But again, we account for that, and we expect our accuracy claims include all weather, not just perfect sunny days during the daylight. That those accuracy claims are across the spectrum.
Is there a way to change the preset class filters on the Armadillo?
No, there's not. Those are preset and are not adjustable.
To the question before about bouncing, what about wind impact and vibration of the mast holding the radar?
Again, it kind of depends on how much you're talking about. There is some forgiveness built into it. The tracker can actually probably withstand a little bit more sway than the SpeedLane can, just because of it being a forward firing device. Whereas the SpeedLane, with the lanes more rigidly set, the more sway that you have, the more likely it is to misplace targets in the incorrect lane if there's more than a few inches of sway. There's not necessarily a wind load study done to determine it, because again, it depends on each location with how far away, the kind of ranging you're using for the detection zone. There's just not a clear-cut answer, because every situation would be different.
It looks like all the questions.
Wow, we had quite a few questions there. I hope everyone is happy with the answers that they received, and if there is more information you want, again, just put a note into the question area and we will reach out to you to further conversations. So if that's it, oh, sorry, Casey?
No, that's all I have, Sheri. Thank you very much.
All right. So on the last note, we would like to invite everyone to our next webinar, which will be on March 3rd, the same time. MyoVision's Intersection Health, MyoVision's new cutting-edge tool that brings problems to the surface to review and prioritize, allowing you to fix issues. All attendees will receive a follow-up email with a link to the presentation and a registration link for our next webinar. We hope you enjoyed today's webinar. Once again, Casey and I would like to thank you for joining Stinson ITS and Houston Radar.
Thank you very much.